Alright guys, this is the final thing that we're going to focus on, and I want you guys to put on the top of your title, go ahead and put identity matrix. Alright? Couple things that I'm going to specify this. You need to have a perfect square. You're going to be able to see right here, you need to have perfect square. So you need a perfect squared, which is just your columns and your rows and your columns are the same. For example, 5 5, 3 3, 9 9, 10 10. I mean, I don't think we're ever gonna get to that big a matrix, but yeah, that's basically anything that has the same rows and the same columns is considered a perfect matrix. Now, the thing that we're going to cover today is that we're going to be looking at a matrix and the inverse of a matrix. So I'm going to show you by looking at question number 1 here, because I want to make this video as short as possible so you guys can focus more on the other ones and this one not so much. Because right now we're just focusing if we get the identity matrix at the end. So let's say this one, the first one, I want you guys to label it. And make sure you copy this whole problem right here. We're going to be working with 1, and then we're going to try and let you guys work on number 2 by yourself. So let's work on number 1, and number 2, try and work it yourself. Okay, so I want you to call that one A. Don't put the 1 in front of it. That was weird to me. Just put A. Now, the second one, what this book is saying is that one's going to be the inverse. And what the book is saying, if you multiply both of them, you're going to end up getting a identity matrix, AI, which is, you're going to be getting that one. That's what they're saying. If you multiply this one with this one, you're going to get this guy right here. Okay, that's what they're saying. That's what they're telling us. Now we have to see if that's true. In order to check if that's true, we're going to have to multiply. Okay? And you might be asking yourself, what is an inverse? Like, inverse is just means it is flipped. So if I have 1/2, I'm going to put it 1/2, and I do the inverse of it, I'm going to have 2/1. That's it. So they're saying that this guy, A, or in other words, they're saying that this guy right here, it is the flip version of that. Okay, that's all they're trying to say. Now, that's a lot of talking. Now let's try and do the problem, okay? Let's try as soon as we can. I want you guys to write both matrices and try to multiply together. Stop the video, try and multiply both matrices, and then once you're done, come back and see how I did it. So I'm just going to write them both. So, I mean, at this point, you should be doing the same thing. Just writing them both. And then you're going to be doing the problem yourself. So it's 9, -2, -4, 1. Then over here it's going to be 1, 2, 4, 9. Okay, so that was there. Okay, so now you should be back. Now I'm going to do the dimensions for both of them. So I know this is 2 by 2 by 2 by 2. So I'm going to look at the two inner numbers. If they're the same, then that means I can multiply. Are they the same? Yes. So I'm going to go ahead, and I know that I can multiply. Also, I can tell what my answer is going to look like. I'm going to go ahead and look at the last two numbers, or the very outer numbers, and they're both 2 2. So my answer is actually going to be a perfect square as well. So I'm going to go ahead and do over here perfect square. That's n, that's n, that's n, and that's n. Okay? We don't know what those are yet, but we're going to figure them in a second. So I'm going to go ahead and start doing my multiplications and adding as well. So I'm going to be going, if you remember from the last video, you're going to be going on the first matrix, you're going to be going and doing your rows, right? For the second matrix, you're going to go ahead and do your columns. You're going to be going down. So first matrix, you go horizontal, Second matrix, you go vertical and you're gonna go down. Okay? So let's go ahead and do that. So I know I'm gonna start with 9 and 1. That's my first two numbers I'm gonna multiply. So it's gonna be 9 times 1. And then the second one's gonna be negative 2 times 4. Okay? So 9 times 1 is 9. Negative 2 times 4 is negative 8. And my answer to the whole thing is negative 1. Or actually not negative 1, positive 1. So I know my first number right here is going to be a positive 1. Boom, we're done with the first one. Now let's do the second one. I'm going to start with negative, or I'm going to start with 9 again. But now you're going to notice that I'm going to start with 2 on the second one. Okay? I'm still going from left to right and top to bottom from the second one. So left to right. So it's 9. Let me just do 2. So it's going to be 9 times 2. And then it's going to be negative 2 times what? Times 9. So that's 18. Then on the bottom, that's negative 18. So my answer is 0. So the second one is going to be 0. I'm going to go ahead and delete it. So this n is going to go ahead and be a 0. Alright, I'm done with my two numbers on the top. So I'm going to, now I'm going to start from the 4. Okay, but I'm still going to grab the first one. Okay, so let's go ahead and do that. It's going to be negative 4 times 1. It's going to be negative 4. No, the second one's not negative 4. Second one is going to be 1 times 4. That's what I meant to say. Okay. What do you get? On the first one, you get negative 4. On the second one, you get positive 4. So if you do addition, it's going to be 0. So this n right here is going to be 0 too. Okay, finally, the final number, I'm going to go ahead and reset already. And we're going to have to figure out if it's 1, like they say it's supposed to be. Alright, so again, I'm going to start with negative 4. But now I'm going to start with 2. Okay, and now I'm going to do 1 times 9. Going to get negative 8 on the top. I'm going to get 9 on the bottom. And negative 8 plus 9 is 1. And it's positive 1 again. So this is 1. So if you look at your answer, D is equal to the negative inverse of C. I don't even know what to go on. So it is true. We did get what we were supposed to get. So the answer to this problem is yes. Both of them are inverses of each other. Okay, now we're going to go ahead and try the second one. Alright, so make sure you stop the video like I said. I'm going to go right into it. I'm going to write the problems and I'm going to start them. But you should stop the video right here and try and do it if you haven't done it. Okay, I already wrote it down. I know my final answer is going to be a 3 by 3, and it, because everything else is a 3 by 3. Now we just have to make sure that we're going to get the inverse of it, right? So let's go ahead. Like I said, you always going to go this way with the first one. With the second one, you're going to go down. So for the first one, I'm going to go and do 1 times 1. For the second one, it's going to be 2 times 0. And then 3 times 0. What do I get? I get 1. So my first number, let me make more space over here on this side. First number is 1. Now let's do the second one. I'm going to do 1 times 11. Now 2 times negative 1. Now 3 times negative 3. Alright, so we're going to get 11, negative 1, or negative 2, and negative 9. So those two is 11 minus 2, which is 9. 9 minus 9 is 0. So the second one is 0. So far, so good, right? Now let's do the next one. We're going to go ahead and do 1 times 14. It's just a lot of multiplication. So 2, 3. 2 times negative 1. 3 times negative 4. So for this one, we're going to get 14. We're going to get negative 2. And we're going to get negative 12. So if I add those two on the bottom, that's negative 14. And 14, that's equal to 0. So far, so good. Right? It might still be an inverse. We have to check every single one, though. Now, on this one, I'm going to start right here. Going to start with 0. So I'm going to start with the second row on the first matrix. So it's going to be 0 times 1. Then it's going to be 0 times 0. Then it's going to be 0 times... Oh, shoot. No, I'm getting it all wrong now. Let's go back a little bit. It's going to be 0 times 1. Then negative 4. Times 0. And then 1 times 0. So this is a 0. That would make sense. Okay. Now I'm going to continue to the next one. This one has to be a 1. Alright, this is a one important one. So we're going to do 0. Times 11. Then negative 4. Times negative 1. Okay, that makes sense. And then we're going to have 1 times negative 3. So we're going to get 0 in the first one. We're going to get positive 4 in the second one. And negative 3 on the third. So I get 1. So this one is a 1. So far, so good. We're going to continue going through them. Okay. I'm going to start with 0 again. But now I'm going to multiply to 14. I'm going to get negative 4. Multiply with negative 1. And finally, 1 times negative 4. Okay, let's see what we get. We get 0. We get positive 4. We get negative 4. So far, so good. It's 0. Alright. It can still be in the matrix, but like we said, we have to check every single answer. Now the next one's going to be the final row on the first one. We're almost there. We just need 3 more. So we're going to start with 0 times 1, then 3 times 0, then 0 times 0. Okay, this is 0, this is 0, this is 0, so my answer is 0. Almost there. Almost there. We just need 2 more. Those are going to be my last 2. So I'm going to 0 times 11. 3 times -1. And then it's going to be 0 times -3. So I'm going to get 0. I'm going to get -3. And 0. Interesting, right? So if I add them all up, I'm going to get -3. So this one, I got -3. Interesting. So we could actually stop right there. The reason why is because that one's not an identity matrix. An identity matrix for that one should look just like this one right here. I'm going to highlight it for you guys. It shouldn't look like this. But if you can see, we already got what? We got a -3 on there. So this one's not an identity matrix. So we're just going to finish it just to have like the entire thing. But yeah, they're not going to be inverses of each other. And that's all we were checking for. And that's basically it. If you figure that out by yourself, then perfect. I know this video, I said it was going to take shorter, but now it took longer because of this one. This one we had to multiply a lot of stuff. But I still wanted to show everything just so you guys can see. Now I'm going to start with 0. It's going to be 0 times 14. It's going to be 3 times -1. And it's going to be 0 times -4. So 0, -3, and 0. So my answer on the last one is also going to be -3. And that's it. That's all you had to do for this one. And that's where we're going to start with matrices. That was the final thing that we were going to cover. It was just 2 problems, but they take quite a while. Especially the last one, because we had to do a lot of stuff. So hopefully that helps. I try to show every single thing that I did, just so you guys can see it. Now, this is the final video that you're going to be watching this week. So in total, I think it's about an hour long, the whole sessions. I do apologize. I was really hoping I could do it faster, but I just couldn't because there was a lot of stuff on there. We're going to be covering absolute value in class, but this is the last thing that you need to see in matrices. We were a little behind, but now we should be caught up with everybody. Hopefully we can just do a lot better in just like understanding everything. So that's it.